Let's their challenger here. This defense. Tino, has any? Let's go back. Anybody try to solve that problem? Don't know what happened to the diagram. You have two alternatives, right? You have two alternatives. You have defender and challenger. Okay? So in order for you to make a decision if you are gonna replace the defender with a challenger, you are first, if marginal cost is available, if that is available, then compare it with the equivalent uniform annual cost of challenger. Everyone understands what marginal cost is, right? That is the cost for maintaining the system at that particular year for the defender. Okay? But for the challenger, you have to find the equivalent annual cost and then you compare them. Okay? If marginal cost is available. If marginal cost is not available, then you have to find both defender and challengers. This one. EUAC. And then you compare them. Is it still feasible for me or economical for me to maintain this old system for another year? Because you are looking at the cost at a yearly basis. That's why you are doing the uniform annual cost.
And in a problem, would it give us the marginal cost of, like, it would say?
Yeah, find the marginal cost. No? Anyway. Okay, so if we look at this example here where they calculated the equivalent uniform annual cost and the equivalent uniform annual cost capital recovery, a piece of machinery costs 7,500, and that's what they used, right, for everything here. Does that make sense? For all these values here, that's what they used. So it's 7,500 times the finding for A given P. And the problem here says it has no salvage value after it is installed. Okay? So let's go back. This is the value that we need to recover. That's the capital recovery that they gave. The capital recovery cost, there's no deduction because there is no salvage value. So everything is 7,500 minus 0. All here is 7,500 minus 0. Does that make sense? Is that clear? So you see the equation here is 7,500 A given P, right? 8% N. Our problem here states that it has no salvage value, so
there's no
it's 0.
So as soon as it's installed, there's
No.
depreciation value because there's no salvage value.
There's no salvage value. So there's depreciation, but the whole value is what you
depreciates to 0.
Yes. Yeah. So that's what you need to recover is the whole 7,500. Unlike here, diagram.
Well, for the
The problem back here is the cost. Here, in this examination here. But in the first year,
Gender versus challenge.
Dr. Lennon, if something like, say you install something and it like taking it out costs money, would that be a negative salvage value, or would that be something else? Or would
that will be
like,
that will be
that would be a negative salvage value, or would that be a different cost?
that will be a cost that will be subtracted from your salvage value.
Okay.
Okay, so a machine has a first cost of 50,000. Market value declines 20% annually. Okay, so the operating maintenance costs are 3,500, climb by 2,000 per year. And so the first year, or when we get the thing, we get the machine, the price of the machine is, or the cost of the machine is 50,000, right? And the first year, what's the salvage value of the machine? Or the value of the machine? What's the market value?
50,000 times 40.
Okay? The second year, the market value of the machine is you have a good teammate here. He already does his homework. All right. So question now is this the value, if we go,
Isn't that the current value of it?
that's the market value of it, right?
Yeah,
So what do we need to recover?
the amount we lost.
The amount we lost, which is? So what do you call that amount you lost? The depreciation, right?
Oh, yeah.
So the amount you lost for the first year is 50,000 minus this guy, right? So 50,000 times 0.2.
50,000.
That's a depreciation. Okay? That is per year depreciation. Three.
Do we know what the previous year minus this year? It's like 50,000 plus 0.8 minus 50,000 0.8 squared.
No, but that's the amount that you have lost through that whole total.
Okay, you don't want depreciation per year.
No.
You want the total. Gotcha.
Okay.
Let's see, and we'll answer our question.
So, Dr. Guillermo, how would you know if you're supposed to do depreciation? So if you want us to do the yearly one, it would be depreciation by year. But like depreciation is the original value minus the current value.
Yeah, let's answer that question after we have answered this. Get this answer for the problem here. So now, so you have your depreciation, and then you have your maintenance cost of 3,500, right? And that's annually, and then the 2,000 is finding for A given G. 9%. Huh?
What's that one for? The
So here you have your maintenance cost of 3,500 per year, but it increases by 2,000 per year. So if you are gonna, So that's the 3,500 per year. But then you have an increase of 2,000 the next years. Does that make sense?
On, like on an example problem we did on Wednesday, we just added the increase each time. When do you want to do the A given G for the increase versus just adding it?
Is the first year just
We'll answer this question first and then I'll go back to
Okay.
it. Okay?
Perfect.
Okay. So we have 50,000, which was or this one is the one that we need to recover. And we multiply this with A given P. 9%. 4.
So you're
So A given P is 4 is 0.3087 plus 3,500 plus 2,000 times 1.393.
that whole equation is finding the UAC.
4 years, year 4. So 50,000 minus 50,000.
And we can treat that as a present value. Why? Are we saying at?
Huh?
Why is it A given P? Or not A given F?
Oh, yeah, would it be a given that?
No, because it's that the value we need to recover at that 4th year.
So we're putting ourselves in the present value at the 4th year.
At the 4th year. We will go back to this one. I just wanted to make sure we get the 17,240. So this one is 9112.82 plus 35 plus 2,000 times 1.393 is equal to no. We're close. I wanted to explain all these values here. So if we add everything here, 9112.82 plus 3,500 plus 2,786, that will give us 15,398.82. Okay? But if we add 50,000 times 0.8 to the 4th times 0.09, plus 15,398.82 Okay? So that one is just 15,000. Okay? So what we have here is, this is the equivalent uniform cost for recovering what was lost in the depreciation. Okay? This one is the annual maintenance cost. This one is, okay? What didn't we take into account?
Is it value the interest we lost by not putting the money into?
So what's that one?
Uh,
So that one is plus 50,000, 0.8 to the fourth times 0.09.
It's the interest lost by not doing what?
That's the interest lost for the current market value of your machine.
And is that the interest loss for 1 year?
For
what
1
you-
year.
what you could drop in that year?
Yeah, for that year.
Or not putting the money that you.
Because instead of you're still using it, but if you have sold it, you could have gotten that money. So you treat it as a cost that is lost. That makes sense? As an expense on your side. So if you add everything, you will get 17,242.
Case has been cracked.
I got 242. Okay.
17,242. So going back to the question about, are we getting the depreciation from the previous year? But basically what you have lost is 50,000 minus the market value for that particular year. That's what you have lost.
Right, okay.
Does that make sense? So that's what you need to recover.
So this compensates for the interest we weren't able to earn for that year. Do
This-
we also have to compensate for the interest we didn't earn for all the previous years, or is that with the depreciation rate?
So what we are calculating here is the 17,242 is just for the fourth year. So if you go to the third year, you will get a different value for this guy, for that particular year.
Yeah.
So you won't add,
So you don't have to worry about
You
previous
don't
year
have-
interests.
yeah,
lost.
because the previous year's interest is taken into account with this guy here,
Okay. With the depreciation.
with the depreciation and the market value. So the next question is, how did he decide about, so the answer here is 17,240 at 4 years, right? How did he decide at 4 years?
He did it for 1 through 5 and saw it started to go back up at 5.
Yes. Okay, so he calculated everything, but when we calculated it is the capital recovery. So let me write it here for our students who are doing the Science Expo. Capital recovery plus annual maintenance cost. And this one is the A given G and interest lost from market value. Okay. That makes sense now?
Can you explain when you do the A given G versus when you just add the value? is there ever a time when you just add your?
Okay, so if we make a cash flow diagram of the costs that we are adding here, so the first one is the original cost is 50,000, right? But in at year 4, the market value 1, 2, 3, 4 is 50,000, 0.8 to the fourth. That's the market value. So we have lost that money.
Yeah.
So that's the money that we need to recover for here. And so we need to find the equivalent annual cost for that one. That's why there is this annual given P.
Okay.
Okay? Now, the next one here is the maintenance cost is starting at 3,500 per year. So that's why we have the 3,500 per year here.
Okay.
But that one is climbing by 2,000 per year. So it starts at 3,500. So it starts at 3,500. So the second year it will be 3,500 plus 2,000. And then the next year is 3,500 plus 4,000. So if you draw this one, you will end up with the gradient cash flow diagram.
Gotcha.
So the equivalent for this one, for 4 years, is this equation here. So what is the equivalent annual cost for a gradient of 2,000 at 9% for 4 years?
Okay.
That makes sense?
Yeah, I'm following.
Okay.
You might have already said this, but when it says the market value declines by 20% annually, that represents a cost technically, because
So technically,
losing money from the,
you are losing 20%.
yeah. Every
So that's, yeah. So that's a depreciation cost on your part. So that's the thing that you need to recover.
So you could write all of those on the cash flow diagram.
Yes. But if you look at here, is 50,000 minus the decline of the market or of the thing times A given P.
Okay.
Because it stays stated here that its market value declines by 20% annually. Only lose 20%, right? So that's what you need to recover because you have a market value of your machine which is 80% of the final value, which still you can sell.
So that, the final answer is that like a representation of how much profit the company needs to make up for the loss of the depreciation?
No. This is the equivalent annual cost.
Okay. Oh, yeah.
So if we add all this cost here, what is the equivalent annual cost to maintain this machine?
Okay.
Does that make sense? Because we are in this replacement analysis.
Like what you were just saying,
Is lost.
if a marginal cost is given, then find the EUAC of the challenger and compare them?
Yes. Yeah.
So in a problem like that, would we have to find the marginal cost of the defender, or would it be given?
You have to find let's look at the example problem in the one that I gave, if they have. Oh, I think I didn't announce in this class, right? You guys remembered April Brown?
Yeah.
Yeah. So this afternoon is her memorial service. So. So the example problem here is the minimum cost life of a new replacement machine is 6 years. So this is a new replacement machine
So this
with
would
a
be
minimum
challenge.
equivalent annual cost of 6,000. So that is your challenger. Given the existing machine's marginal cost data for next 4 years, when should the existing machine be replaced? Does that make sense? Okay. Okay, so here is an example of finding the marginal cost. So it's just, so when you calculate marginal cost, the difference between marginal cost and equivalent uniform annual cost is, marginal cost is for that year only. Okay? Is-
So that's why on marginal cost, even like your operating and maintenance cost,
yes.
you just add it, you know.
You just add because it's it's for that year only.
Gotcha, okay,
Okay? It's only yearly.
got it.
Everything is and the period is always equal to 1.
Perfect.
Okay, for marginal cost. After year 1, after year 2, or after year 3,
You too.
after year 2. Because does that make sense?
Yeah.
So I think this is, but there are some problems that will require you to find the marginal cost. But this is an example of, okay, this 5,400 is the cost of using the machine for year 1. But then if I replace that with a new machine, I am doing 6,000. Okay? Because it's now it's kind of like, I will not use the present value here. I will use the annual cost because it's yearly now. Okay? The diagram. All right, so let's look at this one. This is another good problem here. A drill press was purchased 2 years ago for 40,000. The press can be sold for 15,000 today, or for 12,000, 10,000, 8,000 at the end of each of the next 6 years. Okay, so it's 40,000, right? Year 1, and then 1, 2. Today is 15,000. And then 12,000, 10,000, 8,000, 6,000.
Yeah, yeah. Like you wanna spend.
Okay.
That's the market value?
That's the market value.
That's the EAC.
Market value. Okay.
Plus you.
The annual operating and maintenance cost for the next 6 years is 27, 2,900, 3,300, 3,700, 4,200, and 47.
Wait, why is it starting at 3 for the next 6?
So a drill press was purchased 2 years ago. So if this is year 2,
Uh-huh.
the press can be sold today for 15,000, right?
Oh, I see what they do.
Okay, and at the ends of each of the next 6 years, determine the marginal cost to extend service for each of the next 6 years if the MARR is 12%. If a new drill press, so now you have your Challenger here, the equivalent annual cost is 7,000. When should the drill press be replaced? Okay, now remember that marginal cost is for that year only, right? Okay. So what will we add here for year 3? What will be the marginal cost?
Don't we need to add the 12,000 times the MAR?
12,000 times plus 12,000 times the
12%. Something annual rate of return.
Can we add up the
Is it maximum annual rate of return from MAR or
MAR,
yeah,
minimum
minimum? Dang.
Ac-
I was on the wrong end of the spectrum.
minimum attractive rate of return.
Attractive, not even annual.
No, not annual.
Dude.
Next, the first R is reasonable. Maximum annual reasonable return.
Sounds reasonable.
Is that the only cost?
well, oh, I mean, we need to subtract or add, I guess, the loss of value, right, to our cost.
Yes. So what's the loss of value?
15,000 minus 12 for the first one,
Okay.
and then 12 minus 10, 10 minus 8.
So plus 15,000 minus 12,000. So interest and then depreciation. Makes sense? And then you add this one. That will be your marginal cost for year 3. So marginal cost, there's no A given P or A given G. Okay.
So as the depreciation would go down, would the next one be 12,000 minus 10,000?
Yes. So that's different from a while ago because a while ago we were recovering the capital. Okay. So marginal cost is just the yearly.
And the interest is,
Just to clarify, I think you just answered it, but to clarify, so for marginal cost, we just look at year to year, like 15,000 minus 12,000, and then use that as our depreciation.
Yes.
Whereas when doing EUAC, we take the initial 40,000, subtract it from the.
Correct, because we are trying to recover the capital.
And then look at, change that to A form.
Correct. Yeah.
So this is simpler and.
This is marginal cost is simpler. Does that make sense now?
And then in both of them, we do the interest on the current value.
Correct. Because we could sell the thing, but because we didn't sell it, or we could just put that money into, yeah, we lost that interest.
so do we just add those all up
Add,
across?
yes,
And find when it is,
add all this one here. Yes, add all this. Okay.
and then what about the market? Do we subtract it from the market value?
Here?
Yeah.
No, you don't do anything for market value because the marginal cost is just the cost to maintain
Maintain, that's right.
the system.
And then the interest would, the next one would be 10,000 times 12%, and then 8,000 times 12%, and then 6,000 times 12%, and so on.
This one here, yes, it's 10,000 times 12%. But then your depreciation here will be 12,000 minus
10,000.
10,000. Okay. Then oh, okay. So here is another example for finding marginal cost. Machine has been used for 1 year, has salvage value of 10,000 now, which will drop by 2,000 per year. Maintenance cost is given. Determine the marginal cost to extend service for each of the next 4 years. So how will we make this one? So you have 10,000 as your starting point, and then year 1 is 8,000, 2, 3, 4, 6, 4, 2. What are the costs associated with this one? Will be 8,000 times 0.08, right? That's your interest lost plus depreciation. The market, or 10,000 minus 8,000, you have lost that one for that particular year. And maintenance of 1250. So you add that. Okay, so that's your